Hey, what's up? It's your old pal, Mr. Cook, and we are going to complete the Unit 6 test review. We got our work cut out for us. It looks like there's, 2 full pages, front and back. But it won't take that long if we know our properties. So we already went through the first 10 problems just using the conversion from log to exponent. So now we're going to use a couple other properties, and they are strictly log properties. There's one log property that says that if you have two logs that have the same base, if they're adding together, then that means that they can combine into one single log where the two numbers that are in the parentheses multiply together. So addition between two logs turns into multiplication of one log. That's one property. Another property is that the log of one number minus the log of another number, when I'm subtracting two logs, they combine into a single log as a fraction, because this minus turns into division. And what happens is that the positive log stays in the numerator, the negative log goes in the denominator. So it just looks like this. So you take two logs that are subtracting and they turn into one log as a fraction. The last property that you need to use for like all of these 8 problems is the exponent rule, and that goes like this. If I have a number that's multiplying on my log, then what happens is that number becomes the power inside of the log. So this becomes log to a power, y to the power of x, like that. So here's what I want you to do, okay? So when you do condensing, here's what you want to do first. You want to, very first thing for condensing is tackle the exponent property first, okay? So that's the one that you do first when you're condensing, exponent rule. All right, so just real quickly, go through numbers 11, 12, 13, and 14 using that exponent rule. So here's what the exponent rule says. If you have some number that's multiplying in front of your log, like 2 and 6 and 5, and 5 here and 20 here, and then 2 here, 3 here, 2 here, and 12 here, what happens is that those numbers that are out front just become the exponents inside the log. So what that means is that this power, this number 2 that's multiplying out front becomes a power on the 6. So this becomes log base 3 of 6 to the power of 2. And it's really helpful to put these parentheses on here. I know that they don't have them on here, but if you add them in, it helps out a lot. And then we do plus, and then we move this power inside of the log, so it becomes log base 3 of 11 to the 5th power. See, the power just moves inside the log in each case. Same thing for number 12. The 2 moves in as a power, so that's log base 7 of 11 squared, minus, and then log base 7 of 3 to the 3rd power, because these powers move into the log. Okay, and then same thing with number 13. This 5 becomes a power, so it's log base 8 of x to the 5th power plus log base 8 of y to the 20th power. And we'll do the same thing with this one. Move the power in, so log base 8 of x to the 2nd power minus log base 8 of y to the 12th power. All right, so once we've gotten all of the exponents out of the way, we then move on to the next rule, and the next rule is taking any addition or subtraction and turning it into one log as multiplication or division, respectively. So it's actually really easy to do that. Once you have established that you have addition or subtraction between the logs, they're either going to multiply together or turn into a fraction. So in this case, when it's adding, these are going to multiply together. So under a single log, it becomes log base 3 of, and then these two things are going to multiply together because they're adding. So it becomes 6 squared times 11 to the 5th. And you can just leave it like that. You don't need to multiply the numbers out or anything crazy. Just leave it exactly like that, and you're done. Same thing with this one. Since these two logs are adding together, these two things are going to multiply together under a single log. So this becomes log base 8 of, and then it's going to be this number times this number. So x to the 5th times y to the 20th. And at this point, you are all done because you've combined everything into a single log, and that's it. With subtraction, it's a little bit different because with subtraction, it turns into a fraction, and the negative part of it goes in the denominator. So for these ones, since I'm subtracting, these two are going to turn into a fraction, so I've got log base 7 of, and then it's going to be a fraction. The negative one, which is 3 to the 3rd, goes in the bottom. The positive one, which is 11 squared, goes in the top. And at this point, you're all done. That's all that you need to do for this. Just turn it into a single logarithm. Same thing works here. It's log base 8, and then it's going to turn into a fraction. The negative log, which is y to the 12th, goes in the bottom, and then the positive log, x squared, goes in the top, and you are all done with that one. So that's the first 4 problems. Let's do the next 4 problems. Expanding the log. So condensing means turning it into a single log. Expanding takes it from a single log and expands it outwards. So we're going backwards on the steps. So if this is condensing, where you do this step first, get rid of the exponents first, and then get rid of the addition subtraction. With expanding, you're doing the opposite. So you want to get rid of any multiplication and division first, and then get rid of any exponents next. So that's how it goes for expanding. So let's go ahead and do that. So I say that, and then I of course need to stop and just kind of throw one little thing out at you when we're before I start expanding all the problems out. And that's if you have an exponent power outside the parentheses, like in number 15 or number 16, remember to distribute that power in, okay? Do that first. Then it makes the rest of the process very easy. So watch what happens, ready? When we distribute the 5 as a power in, it goes to the 12 and also to the 6. So I'm just going to rewrite this. It becomes log base 8 of 12 to the 5th, and then 11 to the power of, and then when 2 powers multiply together, and when you have a power to the power, it multiplies, so it's 11 to the 30th. I'm going to do the same thing with number 16 because that has the same thing where it's an exponent on the outside. I'm going to distribute the 3 into here and also into here. So I'm just rewriting it. It becomes log base 9 of 6 to the power of 12 over 11 to the power of 3. All right, now everything's established pretty well with these two, and that one's fine. This one's a little bit weird because I don't know what to do with that square root. I haven't really talked about it yet. The square root, whenever you see that square root there, it's real easy to just rewrite it as an exponent because the square root is the same thing as saying an exponent power of 1/2. So I'm just going to rewrite this, just the same exact expression, but just rewritten. Log base 5 of c, and then it's going to be the square root of a and the square root of b. So that's going to be times a to the 1/2 power. A is taking the square root, so that means it has a 1/2 power, times b, which is also taking the square root, so it's going to be b to the 1/2 power as well. All right, so now just rewriting those, that helps me out a lot because now it's just these basic little properties that I'm going to use. The first thing that I want to do when I'm at this stage is just split the logs apart. So in other words, turn them into adding and subtracting before I get rid of the powers, because I know that you see those powers there, the 5th power, 30th power, but get rid of the multiplication first. So to do that, this gets split into 2 separate logs. One log is going to have just that 12 to the 5th power on it. The other log is going to have the other thing, the 11 to the 30th power. And then since they're multiplying together, we add those 2 logs. All right, so do you see where else we can use that? We can use that on number 17 and number 18 as well. So let's go ahead and do that real quick. Let's just split these apart. So this is 3 things that are multiplying, so it's going to turn into 3 logs. Log base 5 of u, log base 5 of v, and also log base 5 of w to the 3rd power. And since they're all multiplying, they're all going to be adding the logs together like that. Same thing with number 18. So remember we rewrote it like this, so let's split it apart. It turns into 3 separate logs because we have 3 things that are multiplying. So I get log base 5 of c, and then I get log base 5 of a to the 1/2 power, and then I get log base 5 of b to the 1/2 power. And then since I'm multiplying all this stuff, it's just adding. So the only difference between number 15, 17, and 18, those 3, and then number 16 is that now we're dividing. And do you remember what division is the same as? Division of a log turns into subtraction between 2 logs. So if I want to split it apart, it'll turn into subtraction. So I do very much the same thing. I have 2 things that are dividing, so I write them as separate logs. So log base 9 of 6 to the 12th power. And then also I have log base 9 of 11 to the 3rd power. But now, instead of adding them together, I'm going to subtract them. And the one on the bottom, the denominator, is the negative log on there. There's one last step that we need to do. So we did the first step of getting rid of any multiplication or division, splitting the logs apart into adding and subtracting. Now the last step is to move the powers to the front. So it really is just the reverse steps of what we did here. For this first one, you know, we move the powers in and then combine the logs. Now for these ones, we're separating the logs and then getting rid of the powers. So moving the power out to the front, so this power moves to the front. Same thing with this one, and this one, and this one, and this one. Anytime that you have a power, like even this 1/2, it just goes to the front. So I'm going to rewrite them all. So this one becomes 5 log base 8 of 12 plus, and then it's going to be 30 log base 8 of 11. And that's my expanded logarithm, just like that, all done. And then this one, moving the powers to the front, I've got 12 log base 9 of 6 minus, and then the 3 moves to the front, so 3 log base 9 of 11. And that's it. That's all I need to do to expand it. Now on to this one, move the power out to the front on that very last one because that's the only one with a power. And we get log base 5 of u, and then plus log base 5 of v, and then we move to the 3 of the front, so plus 3 log base 5 of w. And that's it for this one. Now move the exponent powers to the front, these 1/2s, and I get log base 5 of c plus 1/2 log base 5 of a plus, and then the last part of it, 1/2 log base 5 of b. So these are all of our logarithms completely expanded out. So that's the next 8 problems, number 11 through number 18, and just using these log properties that we're supposed to know. All right, so that's it for this video. We're going to move on to the second page, which we're going to turn into looks like solving mostly. And then I'm sure that we'll be able to get that stuff done pretty quickly and then go into another page for the word problems. All right, so that's it for this one. On to the next video.